Hey everybody, thanks for tuning in to Powermaster. I'm Jefferson Bryant from Dirt Rodz, and I'm here to talk to you about alternators, specifically GM's Gen 5 LT series alternator. Now back in 2010, GM switched from an ECM controlled alternator to a BCM controlled alternator that is pulse width modulated. What that does is essentially it controls the voltage of the alternator output. So it can be anywhere from 12.5 all the way up to 14.5. The issue here is that the body control module sends a signal to the ECM, and the ECM then adjusts the alternator. The biggest concern about this is in a swap situation. So if you've swapped a late model Gen 5 engine into any other vehicle, that you won't have the BCM. So your ECM won't really know what output to send to the alternator. There is a setting inside the ECM where you can adjust the output voltage. It still does not remain static. You can just raise it and it will still raise and lower on its own because the ECM doesn't know what to do. With a factory alternator in a swap situation, most people's solution is to simply unplug it. This port right here, you'll unplug it, and then the alternator will automatically default to a fail-safe mode. And that fail-safe voltage is 13.6. That's not really high enough to operate aftermarket equipment like stereo systems and things like that. Can cause a lot of problems for fuel pumps. It also isn't going to charge your battery the way it should. It's just not getting the high enough output voltage. In order to solve this issue, we're going to test both of these alternators in our 1971 Buick GS convertible that has a GM LT1 crate motor. This alternator is a 51794. This is a factory Corvette alternator. This is PWM controlled. This will work in any factory situation with a body control module. This alternator over here is the 517941. This is a one-wire alternator like what you would use for LS swaps or small block Chevys. For years and years we've been using those. We're going to install the one wire and test whether or not it sets the charging system error light in our ECM and see if we can fix it if it does. So we're over here at our car. Like I said, this is a 1971 Buick GS convertible with a GM Gen 5 LT1 crate engine. We are running the Chevy Performance ECM and wiring harness. This is as stock as it gets for an engine swap. No BCM, just the ECM, ready to go. Okay, so we have a factory accessory drive with the Corvette style alternator. This is a factory alternator that comes with the crate engine. We have our clamp meter to measure the amperage on the alternator output cable. And we have a voltmeter here connected to the alternator as well. The ignition is on, so it shows we're pulling about 2.3 amps. We're going to fire it up with the ECM connected to the alternator. That'll show you what the output voltage is. Then we're going to disconnect it and show you what it does when it goes into fail-safe mode. Go ahead. We're up to 14.8, 14.7 volts. We are outputting about 60, right around 60 amps. Okay, now our engine has idled down. We're running about 700 RPM. We have about 30, it's bouncing, but it's averaging about 35 amps at idle. We're running 14.7, 14.8 volts. Just kind of bounces around a little bit. This is part of the problem. The ECM is set to deliver 14.8 volts, but it is still bouncing around all over the place. I've had some issues with this car doing that, and I do believe it is all based on this alternator. Now, I'm going to disconnect the alternator plug, not the output, but the control plug, and watch what happens. It immediately drops down to 13.5, 13.4. it's supposed to be 13.6 is what the output is supposed to be in fail-safe mode. We've also lost some amperage. We have dropped down to average of about 25 amps here. So next thing we're gonna do is take this out, put in the one wire, and see what kind of output we get. With this disconnected, you're gonna see here, we'll pop it up on the screen. This is a screenshot of the codes on our ECM. If this was a factory installed engine in, say, like 2014 Chevy truck, and you disconnected that, you would get a charge light error on your dash, and it would set a check engine light code. So why does idle amperage matter? What is so important about it? Well, today's cars with overdrive transmissions, you can be cruising along at 80 miles an hour, turning under 1500 RPM. That's just off idle. A lot of factory alternators simply cannot provide the maximum amperage at that low of an RPM. So if you have high-powered stereo systems, you have a four-wheel drive where you run lots of lights and a winch, you will do those things at idle. Let's say you have a four-wheel drive and you've got to winch your buddy out of a hole. Well, you're not going to have somebody sitting in your car running the engine up to 2500 RPM. You're going to leave it at idle and run that winch. Maybe you have your big lights. Maybe you have an air compressor running for tools. That will drain down your battery. Your alternator simply can't keep up with that sort of demand at idle. So you want an alternator that will deliver maximum output at low RPMs. These direct fit HPR Powermaster alternators deliver 195 amps at as low as 600 RPM. So you would have no problem running all of that equipment and your engine's ECM at idle. Okay, so we've got our factory alternator out and we are installing the one wire now. These alternators are available with different pulley options. You can get the factory decoupler style or a static solid pulley. Now then, we're gonna go ahead and pull all of this stuff off. So this is a 250 amp alternator. The reason that matters is because we are currently running a 4-gauge charge wire from the alternator to the battery. Powermaster recommends 2-gauge wire if you are running anything larger than 175 amps. We are, so we need to change this. For our tests right now, it doesn't matter. We're going to keep this. We actually need to get a longer wire because this alternator has a second post on it, and that post is a ground post. You will ground the alternator directly to the block. That will give you better, consistent output without voltage spikes, and it ensures that the alternator is grounded properly and not trying to ground through bushings and brackets and gaskets. We picked up this 4-gauge ground wire from Powermaster. So we're just going to slip this on that bottom lug. These are fairly close to each other, the output and the ground lug, so you want to make sure that you're careful and that there's no chance that those two could arc to each other. Now we've got our ground wire connected to the bottom of the alternator, and for testing purposes, we're going to use the upper alternator mounting bolt. For the final installation, once we've made a couple of new wires, we'll have that rerouted and we'll actually bolt it to the block itself. The new alternator is installed and wired up. We have our voltmeter on the battery showing 12.4, and we're showing 2 amps on the alternator output wire. Now we're going to fire it up and see if this all works. We do believe that the factory charging light system will trigger with this alternator because the ECM is not plugged into the alternator. If it does, we're going to remove this cap here, plug in the ECM to the alternator, and the output of the alternator should not change. We're going to test it, find out. Let's fire it up. Okay, so right away, I've noticed a couple of major differences. We're showing around 14 volts charging. It was 14.7, 14.8 last time. but you'll notice that it is sticking right around that 14.4, 14.3 range. Now we're gonna go check the computer and see if the charge light is on. Okay, so now we are getting the generator light with this alternator unplugged. So we're gonna plug it in and see if anything changes. Okay, our running voltage did not change at all, but let's go see if our code went away. All right, so I have my screen here. That's the generator code. Those other two, ignore those are permanent. Just takes a while for those to go away. Now we're gonna hit, boom. Generator light's gone, perfect. All right, and that's it, it's that easy. 2 bolts, a couple of wires, new alternators on, and it's working flawlessly. We don't have a generator code anymore, and the voltage is staying the same rate. We don't have crazy fluctuations, having to drop it down to 12.5, which causes issues. These direct fit HPR Powermaster alternators works really well with our Gen 5 engine. It solves all of the alternator charging issues that are common with the factory alternators. Make sure you check out Powermaster for more information on these alternators, as well as their others and their starters. Thanks for watching. We'll see you next time.